Hello friends, hi there. Welcome to I Talk Code. In this video, I'll be talking about computer networks. See, computer networks is a topic that is mainly dealt in communication engineering, and it is one of the most core topic in computer science. Computer science. So, as we see, that computer networks is interdisciplinary. It draws knowledge from different fields that are algorithms, digital electronics, computer application architecture, and many more. And many more. So, computer networks is unfortunately one of the most misunderstood topic. But if it is dealt correctly, it can be really exciting. Computer networks is often as a bad name for being misunderstood because it has different terminologies. Now, these terminologies are very interrelated, very close, and have very subtle meaning differences in their meaning. As a result, computer networks actually becomes confusing. Terminologies like difference between a standard and a protocol, difference between an RFC and a standard, difference between the different layers are all tough to wrap your head around. Computer networks is actually also misunderstood because it has a very broad scale and there are many different architectures at play. Many different software and hardware paradigms actually exist, which makes understanding difficult. Moreover, computer networks is actually draws knowledge from different fields. So, in this series of videos, we'll be studying computer networks in its typical sense. Many different fields stem out from a computer networks, and very different architectures exist for different types of networks in a computer system. So we can say that network security, network analytics, network and routing, and many different fields actually are sub-branches that arise from the computer networks paradigm. Computer networks is, as I said, misunderstood, but with correct understanding, it's a really exciting topic. And I'm here to bring you to share such an excitement with you guys. See, computer networks can be tough to understand, but with correct guidance, you will be much prepared to explore the world of computers. So, let's get started. So, we begin with the most fundamental question: is what is a network? So, a network, in most simple terms, is actually a way of defining connectedness. And that concept of connectedness is based on connectivism. It is a psychological topic. So, a network is actually a way to define connectedness. And every network, be it be computer network or any other network actually has some entities that are related through some way or the other. Basically, when we talk about networks, it's generally communication that defines these relationships or relatedness. So every network has some entities in case of which act as actors, or which act as the things which actually are communicating physically in a broader sense. Then we have some intermediaries through which the communication can be established. In case of just two people talking, the intermediary might be the air vibrations that can actually serve as a communication channel. And then there can be helpers which will actually help us in causing this communication. So in entities, when I'm talking about, these are basically the things that are actually communicating. So for computer networks, there can be the actors will be the machines that are actually been communicating. Intermediaries can be the routers and packet switches or the devices which actually aid in communication. And helpers can be something which actually help us regenerate the computing signal, or help us amplify the computing signal, help us to maintain the communication easy, helps, or the gateway through which the communication is established. So many different things. So thus a network has some entities, and so these entities are related to in a network they're related to some form of communication. So computer networks are actually also, as the name suggests, is a type of network. And we know that networks can be as simple as some group of people talking or two people talking. It can be as complicated as a sum of bees or ants that are communicating through biological pheromones. It can be as subtle as the nervous system of animals. And if I talk about the internet, it is as conspicuous or as global a network that is well known in the 21st century. So in this video, so the takeaway is that computer networks is a network which has some entities that are communicating, and this communication is done with some devices that act as intermediaries, some devices which act as actors, and some devices which act as helpers in communication. So let's first draw a distinction between a computer network and the internet. See, when we say about internet, we say internet is a computer network. So computer network is something that is larger than the internet. Actually, computer network is not essentially internet, but it can be internet, or internet is a subset of computer network, or you could say internet is a type of computer network essentially. So when we talk about a computer network, it can be other things without the internet. So if I just have a computer network circle, then internet is just a part of a computer network. We can have some printers that are being connected together to a particular device. So that is also a form of a computer network. So it's actually a computer network. We can have some peripherals or the devices with which we can operate upon a computer, like keyboard, mouse, printers, scanners. So these devices, the CD drive or the hard drive, these devices are actually also, you could say, being attached to the computing system and form a network, although they communicate through a mechanism that is different, which is inter-process communication. We'll talk about in the chapter of operating systems. So we can also have some IoT networks. There will be some sensors or career access devices which will be different. So sensors which actually will be different, and that will help us in communication. Different type of sensors, some for monitoring temperature, pressure in case of weather forecasting engines, some for monitoring, if you could say, some monitoring for voice, some sensors pertaining to voice, like microphones for voice input, some sensors like camera for object detection, and computer vision technologies. So we can have a IoT network. So when we talk about computer network, it is not essentially internet, but it can be internet. Now, if we talk about internet for now, see, internet is actually a global network. So when we talk about internet, it is actually global. Talking about in a broad sense that it's a global. It is generally, we are talking about World Wide Web. We're talking about World Wide Web. But internet is actually not completely World Wide Web. Internet, there are actually some websites which actually have that www written in front of them, if you notice, and some websites which don't have www written on that. So internet is not essentially World Wide Web. In fact, World Wide Web is a subset. So if you say this is the internet, then World Wide Web is just a part of the internet. Essentially, when we study internet, we divide it into two parts, which is the surface web and the deep web. Surface web is that part of the internet that can be accessed by the traditional browsers like Google Chrome, Safari, Mozilla, Opera. These are the internet that is essentially considered safe for viewing purposes, and it does not. It is the basically what we essentially use in our day-to-day life. But there is also a flip side of internet which can't be accessed by regular browsers and has some technologies to store data on the internet or for other operations which are sometimes malicious intent, and these part of internet that can't be essentially be accessed through the World Wide Web, so can't be accessed through traditional browsers, but can be accessed using some not entirely legal technologies, web access technologies like using Tor browsers. Or now disclaimer, please, it's not advised to use Tor at all, just talking it for means of education. So we could use Tor as the networking protocol through which the tolerance to mask our IPs and access another part of the internet which is not considered safe for viewing and is actually not legal to entirely use it, which is known as the deep web. And a deep web is the second part of the internet. So first we have the surface web, which can be browsed by the regular browsers, deep web which can't be browsed by the regular browsers, and there's some part of the deep web that is known as the dark web, where all the, you could say, malicious activities or malicious intent take place. So I thought just to bring this into notice, like it is highly unadvised to just even think about browsing about the deep web, and there can be consequences if so a disclaimer for you guys: don't use the deep web. And basically, this video brings us the difference between the computer network and the internet here. So how can we actually define the internet? See, one thing we know for sure, that internet is a global network, and to understand a system as big as a internet, a question pops up in the mind, like, is the understanding of such a big, huge, humongous Uber network even possible? Well, actually we need to break it down. See, internet can be understood only when we view the internet from different standpoints. We can view the internet as how the different physical devices on the network are being laid out, or the understanding the network topology that we call, or which I call the physical view. We can also understand what services are actually being performed by the internet, like in order to maintain the communication. So I said we have some devices which are helpers, which can help us in making the communication easy. So like some services which actually the internet technology uses to leverage, which are leveraged by the some internet computer devices to make communication easy. And there can also be a subtle third difference perspective, is the application level view perspective, which actually pertains around that what can we actually get from the internet, how are the different applications that are connected to the internet they are working, how can we actually build our particular own internet application, how can we build our application and we can tailor our internet application so that it uses only the features that are just according to the needs and not uses other irrelevant features. So these are actually different questions that actually pop up when we are trying to understand and define the internet. So when we talk about how physical devices are connected, we talk about essentially talking about the network topology. When we're talking about how different services are performed by the internet, we're talking about their protocols. And when we're talking about how applications are actually being connected, then it's actually how different software applications are connected, are being pushed into the internet. So these are different done through different frameworks and libraries which actually internally use an API which are built around API, web APIs and sockets which are used for communication in the internet sense. So the main thing is that whenever we want to understand the internet, we have to break our understanding and view it from different standpoints. So let's just understand how this. Let us just begin our understanding with the physical view, like how the different physical devices in the internet are working together. And I try to keep it very simple so that you can be like, so it becomes easy to actually gain an understanding of such a widely engineered and such a huge engineered system. So continue along. So well, then what a computer network is? See, a computer network is actually a group of nodes. Now these nodes are actually computing devices that are connected through links. Now as it's a network, these links are communication links. So computer network is a group of nodes or computer devices that are connected through communication links. And what is a node? Node is something that is a device that actually emits some computing signal. So when we talk about different nodes, we say that the nodes, they emit some information, and this information is actually in binary format. Now this information is not in binary zeros, it's just a sequence of zeros and ones, but is carried in groups. So this group of information is known as packets. In the universal packets are the name that is universally used across different computing network technologies, and we say it's actually some nodes emitting packets of information. So when we talk about packets, we say it's just binary information. So we have some sender and we have some receiver. Through the sequence of through these communication links, information is carried from the sender to the receiver. But though the sender and receiver may be directly connected, or it may have some nodes which can be other computing devices that are actually used which actually are intermediate devices which transfer these packets from the sender to the receiver. So since internet is a universal network, it's a global network, so there is, and every device on the internet is connected to another is somehow connected to the every other device on the internet. So and since individual cabling is not possible, yes, we have millions of computer devices, as you know, different smartphones, different cars and electric devices have been connected to the internet recently. So connecting every other device to each other device uniquely is not possible. So hence, to avoid such over cabling, devices are connected. Some devices serve as intermediaries to other devices. So some nodes or intermediaries exist. Now so these are some other computer devices that arise in between. But hey, we also need to, the information that is actually sent from one computer can actually be sent to other computer, and it is possible that the other computer, that the information goes from computer 1 to computer 2 and finally is finally received at the receiver. So we have different computing paradigms, and each node is actually what is the device that participate in a network communication, and these network nodes communicate using links which are known as communication links. And each node, these nodes, they receive and send a signal which is known as packets, which is just information in binary format. And a computer network is a group of these nodes communicating through communication links. Now I want you to forget computer networks for a moment now and think about another network, or the road network. So if you just say, consider the diagram here. So these are some roads that run through another city, and at each road, at the junction of each roads, we have an intersection, or a chauraha, which we say in Hindi. So we can actually navigate our way around by using these intersections as a turning point and a helper to actually switch across roads. So in this road network, suppose we have some trucks, and trucks, they transport cargo. As you can see, it's that cargo truck technology. So we have some stations at positions, like you could say there is a station at A, then B, C, D, E, F. So we have different unloading or loading houses where the cargo is unloaded and loaded. So we have some warehouses at A, B, C, D, E, and we have a truck, say somewhat here. There is a truck T. So this truck T, it first wants to take some cargo at C and drop it at E. So what will happen in this scenario? Well, the truck can take and travel across a road, or we'll say it will travel across a path. Will travel across a path, so it will go to B, and then it will take a right turn and reach C. Truck will go to B and it will take a right turn and go to C. It will take the cargo from C, and again it will navigate its way and reach E to either of the two paths. So it can take this path, or it can take another path. It can take another same path. So there are various methods with which various paths exist between C and D. So what happens is that the truck, it has to go to B, C, so it leverages this intersection to actually switch between one link to another link. If we just take these things as a switching mechanism, and we consider these roads as links, and we can build an analogy with a computer network system. So the analogy goes like this. We have certain nodes stationed at A, B, C, D, E, and F. A, B, C, D, E, and F. These nodes want to send not a truck but a packet. Packet is that information signal. Want to send a truck or packet from C to E, Now this packet needs to be sent through a complicated interconnected path where there is a possibility of multiple paths to be existing. So we need some intersections, not intersections. We need some devices called routers, and these devices will actually help us to decide the route for the packet, and will help us reach from one node to another node. What actually a router is? A router is a device that is used for routing, or it is used for deciding a route, or it is used for directing and deciding a path for the packet to travel from one node to the another node in a computer network. Now the nodes in a computer network are actually called end devices. End devices. They are called as end devices. Routers are actually called as devices used for routing. Devices used for routing. Now it's just, if you just try to think with a very basic, you could say layman's understanding, you can say that a truck driver wants to minimize the distance traveled. He actually wants to minimize it, so he wants to take a shorter path. So we can have algorithms for routers which are called as routing algorithms to help us determine which path is the shortest, or an optimal will help us decide a path for the shortest path for the packet to travel. When we'll sequentially understand delays in computer network, we'll understand that actually the shortest path is not always the fastest, and it can be a desire, and a fastest path is something that can be desirable. So another approach can be set a path that is the fastest but not the shortest, as those it's not necessary both conditions actually happen simultaneously. So there can be routing algorithms which help us get a path that is the fastest path with the least time. So routing algorithms are the algorithms which help us get an optimal path for a packet to travel from the source node to the destination node. So routers are something which are analogous to intersections, and these roads are something analogous to computer links, communication links. These links actually are helping us to aid in connecting across these different computing nodes. And if you see here in such a network, this are all different nodes A, B, C, D, E and F. Are they directly connected? See, D is connected via an intersection to C. D is again connected to E, but through different intersections. B is connected to E through different intersection. Yes. Now another question that can be asked is that in a typical road network, we can have warehouses adjacent to each other. So we can have D, we can have E to just to the we can have you could say F here and G here without having an intersection in between. Is that possible? So yes, actually it's like the different nodes. A router can actually, there is a possibility that a router actually helps us, that multiple devices are connected to a common channel in a link. It is practically possible in internet. So it is essentially not the case that between two routers there will be only at a maximum one device, one node. We can have nodes adjacent to each other in reality as well. We'll see, these are very advanced episodes, we'll see in the later videos. Okay. Now um, are these links in a road network. Like we can have highways, so we can have uh, highways like metalled road, we can have unmetalled road, we can have, you could say, kachi sadak, that we can have pakki sadak, we can have so and so these different types of roads, they actually impact the speed at which a particular packet is travels a particular truck travels on the road. So like that, different types of roads, we also have different types of links which impact the communication, which impact the propagation time, which impact the latency with which a packet is traveling across that link. And since internet is a global network, we can have different types of links connected together. So we can have this link that is metalled, that is fast. We can have this link which is slow. We can have this link which is again fastest, and we can have this link as the most steady and the slowest one. Yes. And what happens in in a real practical situation, whenever there is actually a faster link, then traffic does not occur in a real road network. But when we have slow links, like we have kachi sadak, we have bad roads, what happens? The traffic clutters. There is traffic in the link, or you could say there is congestion in the link. There is different vehicles, they just don't move, and that propagation speed and the transfer speed from warehouse A to warehouse C, the movement of the truck, the speed of the truck is actually inversely impacted. So similarly, due to heterogeneous type of connections, different types of links which at varying speeds, there can be clutter in the network, there can be congestion in the network, there can be traffic in the network. And this traffic, if not handled, can lead to damages and can make the computer networks at a standstill. So like with this cargo technology, I actually explained to different terms that and different complexities of the computer network. If I just had to shout down the complexities, we can just say कि there are different types of links, so different speeds of transfer. Then I said there are is a possibility of congestion in the network. Then I said there is a need to actually minimize congestion, so that strategy could be to design faster routing algorithms that work on speed, that are fast. So we understood what a packet is and what a communication link is. So I hope this video was informative, and in subsequent videos we'll deepen our understanding about computer networks, and we'll understand different types of routers, we'll understand what are end devices, and how and we'll move from we'll understand things in a very using different approaches, might be like from bottom up approaches or some top down approaches, so that you are able to get hold of an understanding of the computer network system and of the internet as well. So I hope this video did formed you a rudimentary understanding. So keep watching iTalk Code and do subscribe to our channel. Till then, happy coding.